You know that feeling when you have an amazing app idea, and then you start thinking about how to build it? Most apps follow a pretty common app architecture. Apps need data, so there's a database. Users want to access that data, so there's some kind of authentication system. For big files, you'll need some kind of media server, and then an API server combines all of that into information a client app finds useful. But here's the thing, your idea is a really good one, and once you build this app, people will jump onto using it. That's great, but that also means you'll need to think about what happens when it starts to grow. Suddenly, this architecture diagram brings up all kinds of questions. What about new platforms? Is the server secure? Is the database fast enough? How do you scale the API server? Can the media server store terabytes of data? With all of these concerns, you might forget that the reason you started going down the spiral of worries is that you had a great idea that will gain users quickly and you want to implement it. If only there was something that would let you do this more easily. Something where you can trust that will keep running smoothly if the app goes viral and can scale from one user to millions of users without having to adjust any infrastructure. What might that be? Firebase. And so, what is Firebase? Firebase is Google's client-side app development platform. It's based on Google Cloud, and Firebase integrates with several other Google tools such as Analytics and Ads. And as it's built on Google infrastructure, it is designed to scale. Regardless of what platform you want to build on, Firebase supports a lot of different client app platforms. There are client-side SDKs for iOS, Swift, and Objective-C, Android, Java, and Kotlin, Web, JavaScript, and TypeScript, as well as frameworks like Angular, React, and Vue, C++ and Unity for game developers, and Flutter. Firebase is a suite of almost 20 different products and is intended to help you through the life cycle of developing apps, which typically goes something like this. When you're first starting out, well, you'll need to build the app. These are the products that can help you do that. There's authentication that enables you to know a user's identity and to authenticate them to your app. Cloud Firestore and Realtime database, which are both NoSQL databases. Cloud storage to help you store big blobs of data like photos, videos, and audio content. And hosting, which helps you put your web app onto the internet. After your app is built and deployed, you can monitor its performance by using Crashlytics and performance monitoring, and you can fix bugs and use TestLab to test those fixes on all different types of devices that you may not have lying around at home. Once that's done, your app will hopefully reach a stable state, and you may want to grow your app to attract more users as well as retain the users you already have. To do so, there is cloud messaging and in-app messaging to send notifications if you want to remind users about purchases or events. A/B testing to test any change before rolling it out to all of your users, and remote config for serving different user experiences based on user properties without needing to ask your users to download a new version of your app. These products will help you decide what your users like in hopes of making sure they continue using your app and get more people to use it too. Firebase does have a large variety of products, and the good part is you can pick and choose which ones would help you most in your app. To use any of them, you just have to install the Firebase SDK to whatever platform you're using to build your app, and most of these products entail just a few lines of code to get the feature up and running. Alright, so now that you know what Firebase is, let's talk about using it to build out a new app. An expense tracker. As a person who really cares about how I'm spending my money, I really want to keep track of my expenses. What I actually do now is keep a spreadsheet of those expenses. I look at my receipt and manually enter the date, vendor, item bought, and amount spent each time I spend money. And this is mostly fine until this happens. Having tons of expenses because I procrastinated and let my expenses pile up, or I went on a business trip and have a ton of expenses from all those taxis I took and each meal I had, on top of the flights and hotel expenses. It becomes quite painful and tedious to manually enter all of this data. In large quantities, It's just really not that great of an experience to have to manually input the date, vendor, item bought, and amount for all of those receipts. So how might an app make this better? Instead of having to manually type in the expense data for all of those receipts that I'm keeping around anyway, let's make an app to let users conveniently scan receipts, and the app will automatically extract the relevant information from those receipts. That way, the app does all the work with just an uploaded receipt image, and it can send extracted information to the user for verification. The user no longer needs to do any manual work other than taking a picture of the receipt. So, what will the user experience? First, they'll upload images, either by taking a photo through their camera or by choosing an image they already have on their phone. Then, behind the scenes, the app finds and extracts the text by scanning the receipt to parse for information like date, vendor, item bought, and amount spent. Finally, the app will relay the extracted information back to the user who needs to confirm it. Diving deeper, here are the app requirements. Be able to securely upload the receipt images, store these images and extracted text, and do image processing on the uploaded receipts. Sounds quite complicated, but let's see how to do it. The first step mentioned is to secure image upload, which means users need to be able to sign in. I don't really want to spend my precious time building an authentication system, and it would probably be quite tricky to get the security of it correct on the first try. Also, as a user of a lot of apps myself, I know that I don't really enjoy creating a new account for every single app that I use. It gets repetitive to set up an account with my first name, last name, email, birthday, the name of the street I grew up on, and so on. Then I have to remember my password, which I probably will not be able to do since, well, everyone supposedly uses different password for all the millions of accounts that we have. It would be really nice to not need to create a new account to use this app. Well, there's Firebase Authentication. Auth provides identity as a service, meaning it lets you know who your user is. It also provides a rules system that lets you grant or deny access to resources and other Firebase products like Firestore and storage. Auth also is ready to use out of the box, and it gives some advanced functionalities like email verification and account linking. Regarding the concern about not wanting to create a new account, Firebase Auth works with many third-party identity providers, including Google, Facebook, Twitter, GitHub, and more. Once users sign in with one of these services, the user gets assigned a record within Firebase's system. This includes a unique user ID and a signed web token, so you get a consistent representation of your users, and one that you can use against both Firebase's services and your own custom servers, no matter how they sign in. So let's see some code for how to let a user create an account using email and password, log in with that account information, sign in with a third-party provider in case they don't want to create a new account, and check whether the user is logged in. First, let's talk about enabling our users to create accounts via email and password. To do so, you would have to first make some pages for the user to create an account, as shown here. Assuming the users fill in both username and password, you can then write some Firebase auth code to create an account. Taking the email and password from the previous screens, call create user with email and password, which will result in either a successful creation of the account or it'll error. If it errors, you can handle the errors here. If it succeeds, you'll be able to see the user's new account in Firebase Console, which is a web portal to let you manage and view Firebase usage for your project. In this case, you'll see all users, what provider they used, the date the account was created, and the unique user ID identifying this user throughout your app. Alright, so that was how you implement code to let a user create an account. What if you need them to sign in with that already created account? Let's say this is the screen for it, and the user again types in the necessary information. Upon pushing the submit button, call sign in with email and password, and again pass in the email and password from the screen, and this will again result in either a success or an error. If it fails, you can handle the errors here. So now let's say your users do not want to create a new account to use this app. So you'll let them sign in with a third-party provider. You'd need to create an instance of the Google Provider object, which says to use Google Sign-in. If you wanted to use Facebook, Twitter, GitHub, and so on, you would use those respective providers here. Next, have the user authenticate. There are two ways to do this, either by opening a pop-up window or by redirecting to a sign-in page. What's shown here is signing in with pop-up, and pass in the provider into that function call. What this says is, use Firebase Auth to sign in with a pop-up using the Google provider. Finally, handle the cases of a user being successfully signed in versus not. So this is how you could implement auth using third-party providers with just a few lines of code. You've seen up to here about how a user can create an account, sign in with said account, and sign in with a third-party provider. Now, you'll see how to check whether a user is logged in already or not. Whenever create user with email and password and sign in with email and password get called without an error, the on-auth state changed function gets triggered. If there is a user, then the user is signed in. Otherwise, no user is signed in, and the function got called because the user logged out. This function will return a user whenever create user with email and password and sign in with email and password get called successfully, as well as with third-party providers such as Google, Facebook, Twitter, and so on. Once you have the user, you can also get various information about the user like display name, email, and their user ID as shown here. Great! So you've seen how users can create accounts and log in, as well as how to know whether a user is already logged in or not. One last tidbit. Even though the code is already not much thanks to Firebase Auth for all of these steps, it is still quite a bit of work to actually make these sign-in screens. Sign-in screens with multiple third-party sign-in buttons, or a create new user screen, or screens to reset and change passwords. And if that's not where you want to spend your development time, you can use the Firebase UI library, which handles all of these cases for you. It's an open source library, so you can customize it as you would like to fit the look and feel of your app. You've now enabled user accounts, and the next thing a user will want to do after logging in is upload a receipt. Let's say there's a screen to let the user upload a receipt, either by taking a photo of it or by choosing a file that already exists. Once they do that and upload it, it needs to be stored somewhere. What should the storage system be like? Well, as users might be using many different image types, the storage system needs to handle that. It also needs to work well even with spotty internet connections. And lastly, as users might upload many receipts, the storage system needs to be able to store all of them. While these receipts are added, hopefully a team does not need to keep an eye on usage to adjust that storage capacity. Cloud storage was designed with many of these concerns in mind. It lets you store many image types, and on top of that, it lets you store and serve user-generated content like audio and video. It's generally used for storing big blobs of unstructured data that you do not need to change too often. To store a lot of receipts, the amount of storage will scale automatically, meaning that storage space will increase as you have more content, and it'll decrease as you delete content. You will not need someone sitting there manually managing the amount of space your app is taking up in storage. Sometimes, internet connection isn't so great, and it's not ideal for half-uploaded receipts to be dropped because the internet was spotty. Storage takes care of this and handles retrying and resuming uploads and syncs whenever a user's phone gets back its internet. After the receipt is uploaded, it can be shared with other users instantly. So this means that if the user's parents wanted to look at the receipts for whatever reason, they can right after uploading. But a user probably doesn't want to just let anyone be able to see their receipts. To protect the user's assets, there are security rules you can set to protect them, And these rules can say who is allowed to read and write certain files in cloud storage. Now, let's look at some code to upload files. Firebase Storage supports files from JavaScript file and blob APIs, bytes, and various string types. Where are we going to store it? Files are stored in a cloud storage bucket, and the files in this bucket are presented in a hierarchical structure, just like the file system on your local hard disk. By creating a reference to a file, your app gains access to it, and a reference can either point to a specific file or to a higher level node in the hierarchy. A reference can be thought of as a pointer to a file in the cloud. To create a reference, call getStorage, then call ref with the former as an argument. This reference points to the root of your cloud storage bucket. From there, you can create a reference to a location lower in the tree. In this case, you've created a file. Now, with the reference, you can then upload it to cloud storage by calling upload bytes, which uploads JavaScript files, blobs, or bytes. You'll pass it the file reference and the information you want to store there, the file itself. The file will then get uploaded, and you can do any post-processing needed after it does so. If you want to upload a string, use the uploadString function and pass in the reference, the string to store, and the string type. So now you've enabled users to upload receipts and put those receipts into storage. Next up is processing the receipt and extracting the text. But processing on the client side, which in this case will probably be a phone, might not be the best idea. Why not? Well, once you write your top secret code to process the receipts, it would be pretty bad if anyone could take it along with the data. Requests coming in from users' devices might be trying to steal it, so something to help with running code against your data securely would be ideal. Also, for both Android and iOS users to be able to use your app, you'll have to write code to process the receipts twice. It would be much better if you could write it once and have the code run, instead of writing it once for iOS and deploying to the App Store, and writing it once for Android to deploy to the Play Store. Also, if you deployed the app separately, iOS users might get this awesome feature first, and Android users might get mad. We definitely don't want that to happen. And remember, you're looking to process those receipts, which probably means running some text recognition on those receipts. This might be CPU intensive, and running highly intensive code off of users' devices might drain a user's battery. Cloud Functions enables you to run backend code in the cloud. It's in a secure environment, and you can write it once for both Android and iOS. To run code, you can trigger it based on platform events or a HTTP request on both platforms, and since it's running on the cloud off of the user's device, this will not drain their battery. Best of all, you can basically run backend code without managing any servers. Using Cloud Functions to run the processing code, what are the functions actually going to do? Well, some machine learning can help extract the information from the receipt, also known as optical character recognition, or OCR. This should get automatically done, but machine learning, turns out, is not a trivial task, and usually a team will need a data scientist or a machine learning expert to build and train models. To serve these models dynamically, the team will need to build up the infrastructure to do that. And that's before you can even write the client code to interact with the model and generate predictions. This sounds like a really long and involved task. Instead of needing to build out your own models, you can use Firebase machine learning. What is Firebase machine learning? It uses Google's machine learning models to help with different machine learning capabilities, depending on what features they're looking at to add to your app. It can recognize text or barcodes from an image, translate text to a different language, or identify important objects in a photo. No machine learning experience is needed. You just need to call these Google Cloud Vision and natural language APIs in your app, and you're basically ready to go. While these libraries can be useful in many situations, what if you have some machine learning needs that do not fall into one of these categories? Well, Firebase Machine Learning provides convenient APIs that help you use your custom TensorFlow-like models in your mobile apps. To do OCR, we can use text recognition. So now you've used machine learning to extract text from the uploaded receipts. What's next? After you get the text back, it needs to be put in a secure environment. There will probably be a lot of extracted text, and this text should be quickly accessible from anywhere in the world. Where should you put it? Cloud Firestore is a good option. As a reminder, earlier I talked about storage, which is used to store the receipt images. Storage is usually used to store big chunks of data like images, audio, and video. Cloud Firestore, on the other hand, is a NoSQL database where you can store data like strings, numbers, and whatever else your app requires. Firestore is used more for structured data that you might be changing often. So while receipt images are stored in Firebase storage, the processed text returned from Firebase Machine Learning will be stored in Firestore. Very similar to storage, Firestore has security rules so clients can talk to the database directly, but you can still make sure they only get access to the documents they're supposed to see or modify. Let's dive a bit deeper on how Cloud Firestore is structured and how to use it. It's a document model database, which means that all of your data is stored in documents and collections. You can think of a document as something like a dictionary or a hash table. It has a set of key value pairs, referred to as fields, and the values here can be a number of different types, anything from strings to numbers to binary values to JSON-looking objects called maps. So here's the document containing the fields previously shown. Each document is stored in a collection. Documents cannot contain other documents, but they can point to collections that contain other documents, which can then point to sub-collections, and so on. In this example, each document will contain information from one uploaded receipt. Here are some examples of what that might look like. Each receipt document contains some values, including the user as identified by their user ID given in Firebase Auth, the date, amount, vendor, item, whether the user has verified these details yet. All of these will go into one collection, a collection containing all receipts. With code, it will look like this. First, add a document using add_doc, and the first argument is which collection to put the document in. In this case, put it in a collection named receipts. What should get added to each document in the collection? Well, you'll add the key value pairs seen in this receipt. You'll also want to say whose receipt it is by providing the user ID provided by Firebase Auth earlier. When the document is successfully added, you can do something with that, and when there's an error, you can handle it as well. In the Firebase console, this is what Firestore looks like. As seen here, here's the receipts collection, and the document name is a random string made up by Firestore, which automatically gets generated when add_doc is called. Inside this document, you can see all the fields put in when add_doc was called. Now that you've added the extracted text into the database, how do you get that data out of the database to send it to the user to ask them to verify the information? Since you'll want to get not all of the receipts that exist in the collection, but instead only want a specific user's receipts, you can write a query to do that. To do so, use Firestore's query function with the first argument again being the reference, which is created using the collection function with the Firestore service and the collection name, just like for the add_doc Firestore function. The other arguments for the query function will be the queries, and you can use where, which takes a field to filter on, a comparison operator, and a value. In this case, you'll get all of the receipts where the user ID equals the function's UID parameter. You only want to get the documents that the user has not verified, so you'll have another query where you check for that. With that query, use the getDocs function to get the documents that satisfy that query from the receipts collection. With what you get back, you can then loop through each of the documents and send the information to the user to verify. As a side note, in Firebase, there are actually two database products. One is Cloud Firestore, which I just talked about, and another is Realtime database. The major differences between these two is that Cloud Firestore is faster at reading and has better querying capabilities, and Realtime database is faster at writing. The reason for these differences is how data is stored in each one. Firestore stores data in collections and documents, whereas Realtime database stores it as a giant JSON tree. If you want to find out more about their differences and help figure out which one you should use, there's a link to a doc specifically talking about that. Now that you've extracted text by deploying functions that run text recognition in machine learning and finally stores the results in Firestore, what's next? You'll need to notify users that the app has the receipt information and ask them to confirm it. How? Let's send a push notification by using Firebase Cloud Messaging to tell users to confirm their receipt amounts. Firebase Cloud Messaging, or FCM for short, is a cross-platform messaging solution that lets you reliably send messages at no cost, and it can deliver hundreds of billions of messages per day, with most of them delivered in less than 200 milliseconds. Users uploading receipts probably all use different types of phones. With FCM, you won't have to invent your own notification system for each phone because FCM delivers notifications to anyone using Android, iOS, and the web. FCM does not need you to track what kind of devices your users are using, and you also do not need to set up different service calls to different devices. Firebase will automatically do that for you. Lastly, you're not only limited to using this to remind users to confirm their receipt information, you can also use it to announce new features that you're launching. For other apps that are not this expense tracker app, you can notify users for things like letting them know their last message was responded to, sending out discount offers, and reminders about events. So now you have notified users to confirm their receipt information, and you'll store this response back into Firestore. Now that you've built the app, the next step is launching the first version of the app. Yay! Before doing so, it's important to make sure that the app is bug-free and stable so that you can make the best first impression with your users. When it comes to catching bugs, it's much better to find them and eliminate them in development rather than after your app has hit production. That means testing your app on as many devices and as many configurations as you can. You probably care about providing a high-quality experience, but you might not have all of the resources to hire a full QA department nor all the potential devices your users might be using. If you really want to test on all the available devices out there, both on iOS and Android, and against all the major operating system versions out there, well, that can get time-consuming and pricey. This is where Firebase Test Lab can help. It does a lot of the heavy lifting to find bugs before you ship to the App Store. With Test Lab, Firebase provides the infrastructure for you, as we have a massive collection of real, physical test devices hosted by Google sitting in our data centers. These devices are for a variety of screen sizes, OS versions, and manufacturers. We cover all the bases so that you don't have to. As Test Lab runs your tests, it'll provide log files, screenshots, and a video of the test lab interacting with your app, making it easier to debug problems. Test Lab will tell you if it runs into cases where the app crashes, freezes, encounters warnings, has accessibility issues, policy violations, and performance problems. It can even spot problems with your user interface, like a button that does not fit on the screen. Testing in this way using different devices is a great start. But what if you don't want to just use the machines to do the testing of your app and want to know more? More about your app that a machine just can't give you feedback on. When you want feedback from actual human testers, you can use app distribution. With app distribution, you can distribute your app to a list of trusted testers and even whole testing teams by sending them email invitations that walk them through the onboarding process to become a tester. You can then notify testers within the app whenever you release a new build for them to test. And in the Firebase console, you can see the status of each tester for specific versions of your app. By this point, Through using test lab and app distribution, you've hopefully caught a lot of bugs and user experience issues. You fix those bugs, and long last, the day has actually come. You decide that the app is really ready to launch now. Right now, the app is just sitting on your laptop or perhaps in GitHub. You built the app for mobile like Android or iOS, which is the most likely chosen platform for this particular app, so you'll have to figure out how to put it on the Play Store or the App Store. If you build this for the web, you can use Firebase hosting to get it off your laptop and actually deploy it onto a website for people to use. So let's talk a bit about Firebase hosting. It's a way to host your web apps, and all you have to do is install the Firebase command line tool and write a single command: Firebase deploy. Firebase hosting has a global CDN, so accessing your web app will be faster because the place to get the content from is physically closer to the user. Sometimes you'll have to update your web app after deploying it once before, whether it's because you changed some content, added some features, or whatever other reason. When you do this update and redeploy to Firebase hosting, it's atomic, meaning all of the servers get updated with the new app, and all the caches get purged. This way, the user is guaranteed to get the latest version. So now with your app out in the wild, you want to ensure that your users are having a smooth experience. Even though you did a lot of testing before, I think we all know that no amount of testing will catch every single problem in your app. Unless you're a magician, in which case, can you teach me? In the case you're not a magician, you'll need to catch and diagnose these problems. And Crashlytics is a good way to do that. Crashlytics is a lightweight, real-time crash reporter that helps you track, prioritize, and fix issues. It groups crashes by root cause, displays associated stack traces, and highlights the circumstances that led up to the crash. You can also configure velocity alerts that will let you know when an issue suddenly increases in the number of users impacted. So just by installing the SDK on Android and iOS, Crashlytics logs crashes that occur in your app and all of that information in near real time to put into an understandable dashboard that lets you see exactly how your app is performing from a stability standpoint and what issues you should focus on first. Here's an illustration of what a typical dashboard might look like in the Firebase console for an app that has been using Crashlytics. But not every complaint you're going to run into is due to a crash or an exception error. Sometimes your app can just be slow or unresponsive, and people are generally impatient, especially when it comes to the time it takes to load a page. They really don't like to wait around for your app to start up or load that initial dataset. It does need to be fast. And you might think, well, that's fine. I've tested my app and it performs great. But you've probably been testing it at work or at home on a modern machine with decent Wi-Fi. Your users, on the other hand, might be all over the world with all sorts of different devices, using all different types of networks with all different types of connection speeds. You need insight into what your users' actual experience is like when they use your app. And so to help you with that, there's performance monitoring, which reports on how your app behaves with users out in the real world. Again, just by installing the SDK, you'll get a ton of important performance metrics reported automatically for you, essentially telling you how long it takes to complete certain tasks in your app and collecting a lot of metrics and attributes of the user along the way. More specifically, it will automatically monitor the cold launch time of your app, HTTP transactions it performs, and how long your users are spending on each screen. If you suspect that some part of your app might be slower than you expect for some users outside of these areas, you can measure that for yourself. All of this information is organized into a dashboard in the Firebase console, and it will help you drill down into the specific devices, regions, and mobile connection speeds of your app that are the most problematic. This way, you can spend time optimizing the experience for the users who might be tempted to rate your app poorly, and you can find out if your optimizations actually improve the experience by comparing the metrics between app versions. By using tools like Crashlytics and performance monitoring, you're able to not only monitor your app, but also hopefully fix any issues your users are facing, And then you can use test lab and app distribution to ensure those issues are indeed fixed. Afterward, hopefully your app reaches a stable state and has a minimal number of huge customer impacting bugs. You then start thinking about growing your user base and retaining the users you already have. To do so, you might think about adjusting various aspects of your app, but you're worried about continuously asking users to download new versions of the app for each adjustment. You're also thinking about adding new features in order to keep your users engaged, and keeping track of development branches in doing so is a bit complicated. To help you with these problems, you can use Firebase Remote Config. What is it? Well, as the name suggests, it pretty much enables you to remotely configure your app, whether you want to change the functionality of your app, the user interface, or some user experience. What this actually means is that you can fine-tune your app behavior with conditions that you predefine without asking your users to download a new version. This sounds pretty useful as a mobile developer, but if you're a web developer, you might be thinking, well, I don't need to do that anyway, so what's in it for me? Remote Config also has targeting capabilities, so you can customize and personalize your app with analytics-based targeting, meaning you can choose types of users to serve some experience. It works by storing key value pairs in the cloud, and for every key, you give it a value based on the type of user. The key is what you're going to use in your app code, and after setting up the corresponding values per user type, Remote Config will serve the correct value automatically to the user. To learn in great detail about how to use Remote Config to launch new features with the help of feature flagging, feel free to check out the video linked in the description about precisely this. Other ways to use Remote Config include adjusting the look and feel of your buttons, the difficulty levels of your games, how you're showing ads, or the way items are organized in your store. Basically, for everything you've got stored in some constants file somewhere, wire that up through Remote Config, and you'll have the power to change just about anything within the app directly from the Firebase console without having to republish anything to the app stores. And so now you know how to change your app seamlessly. But how do you know those changes are optimal? Even if you saw an uptick in app usage, how do you know that that was due to the changes you made in your app instead of random chance, other changes in the app, or maybe a promotion that was running at the time? Well, instead of just relying on hunches or confirmation bias, you can prove it with data. And this is one of the other use cases of Remote Config with a special feature called Personalization. You set a few alternative user experiences and choose what to optimize, and Personalization will automatically provide users with one of the several alternative user experiences, the alternative that optimizes for the objective you choose. You can again find a link in the description about Remote Config Personalization. Another way to confirm your app changes are good is to use Firebase A/B testing, which consists of creating experiments within your app and letting A/B testing tell you which option is best for your goal, which can be to improve retention, increase in-app purchase revenue, or have more users complete your onboarding flow. With anything that can be measured in analytics, you can make it a goal. You'll set up the experiment in the Firebase console, and then you could just sit back and relax with your friends in the nearby hammock. Firebase will do the rest of the work for you. When it comes back with which one maximizes your primary goal the best, you can then roll out that option to your users, confident that you'll get the best results. Both Remote Config Personalization and A/B testing seem to have the same goal, which is to choose an optimal user experience based on data. Why are there both of these in Firebase? And when should you use each one? Linked in the description is documentation and a video addressing this question. So there you have it. The app is built, tested, launched, monitored, and has grown in users. First, you successfully built an app from beginning to end with full functionality. You let users log in via authentication, upload receipt images which then get stored in storage, trigger functions to do OCR using Firebase machine learning to extract details from the receipts, which then get stored in Firestore. Next, you run functions based on values being written into Firestore to automatically send a cloud message to a user to have them confirm their receipt amount. You then use Test Lab to test your whole app on various devices and distributed the app for even more testing using app distribution. Afterward, you put it up on a website using Firebase hosting so people can start using it. Then not only kept an eye on any crashes that might occur using Crashlytics, but also monitored performance using performance monitoring. You thought of serving different user experiences to various audiences by using remote config, and you used remote config personalization and/or A/B testing to ensure that the data has proven you're indeed serving the best user experience to your users. The best part of all this is you did not have to write very much code nor set up much infrastructure to accomplish it all. Yet, here you are. If you're interested in actually building the expense tracker app using Firebase and React for web, you can find a link in the description for the series I created that takes you through the entire process. You're given code to follow and implement along with the videos, and the videos deep dive into the implementation and the products. I hope the information covered here today is useful in your app development journey, and we cannot wait to see what you build using Firebase.